Hello friends, in this lecture we are going to talk about array lists, which are a form of collections that are used to hold many different things in a way that is similar to an array, but it's a little bit more cool. So this is the first time that we've looked at something that's outside of the general definition of the language. It's part of the language in both cases. Array lists in Java and lists and array lists in C exist, but in each case they're going to have to be imported, or they're going to have to be used when you try to use them, because they are not directly part of the language like a standard array. They're an additional package that you effectively have to add in when you're using them. All right, so why would we use these? Well, we've seen arrays, and you can have an array of numbers, and you can say in cell 0, put this number, in cell 1, put this number, in cell 2, put that number. But the downside of arrays is that they're a fixed size. At the time that you create the array, you have to define that it's going to be an array of size 10. And then it can never have more than 10 things, or an array of size 100, and then it can never have more than 100. So why does this matter? Well, the problem is that you're left guessing what the right amount is going to be. For example, let's imagine that I'm going to allow people to enter in KSU IDs, and I'm going to store them. Well, how many should I make the array in the beginning? How big should I make it? 1,000, 10,000, 100,000? How many students is KSU going to have in 45 years? I have no idea. So what's the correct answer? Well, 1 million? Okay, well, they'll definitely never have 1 million. Statements like that always come back to haunt you, because sooner or later you will have more than the number that you assumed it was going to be. So you're going to end up having to pick a really large number, and the problem with that is it uses a lot of memory when you do that, which is not ideal. So it would be better if we could have an array that, much like an accordion, could shrink and grow as you use it. As you add numbers into it, it just gets bigger and bigger and bigger, just the size that it needs to be. When you remove things out of it, theoretically, it gets smaller and smaller. It's not exactly what happens with an array list, but it's basically what happens. The reason I say it's technically not exact is that it really starts off with an array list that's like 10 or 16, and then if you put in a 17th thing, it just grows it, and it pretty much doubles it, makes it like a 32 now, and then when you grow past 32, it adds another 32, and so on. It doesn't actually add it one for one, because that's a lot of work to do that, so it just kind of says, okay, we'll give you 10, and if you use more than 10, then we'll figure it out then. All right, so that's the basic idea of what we're doing with array lists. The cool thing about them is that they work directly with for each loops. So if you're wanting to put stuff in and then work through them, you can absolutely do that with a for each loop. So once again, an array list in Java, a list in C# or an array list in C#, there are two different things in C#, and I'm going to cover the difference in those in a moment, are both considered to be linear data structures. And what that means is you're effectively storing all of the answers in there in an array. It's similar to a 1D array, but it is dynamic. It can grow and shrink as needed. It can be accessed as a 1D array if you're in C#. You can just put the square brackets like you used to and put in a number. If you're in Java, you have to call a method called get, which allows you to get the first element or get the second element, but they are all indexed. As you put them in, the first one is put in index 0, the next one is put in index 1, and you can use it as if it was an array mostly. All right, so array lists in Java. How do you go about doing it? Well, the syntax of this is going to look a little bit weird to you, because this is the first time that you've seen something that's called a generic. We're really not going to cover generics in a lot of detail in this class, but I'm just going to give you the high-level version of it here. So to be clear, this is the line of code that you would add in Java in order to create an array list called names, where the array list can hold strings. Now, this is the part that's new, these angle brackets that you're seeing here with a type written in between them. And that's weird. What is happening here? So the deal is array lists are of a specific type. So much like an array, when you make it, you say it's an array of integers, or it's an array of characters, or it's an array of dogs, whatever your type may be. Array lists are the same thing. But the way that you specify the type is that you kind of pass it in almost like a parameter at the time you're making it. And again, the technical term for this is called generics. And if you want to go look that up on the internet, you're going to find information about generics in C# and generics in Java. And they're going to talk about how you can define classes to be able to take in a type, which is what a generic does. The details of all that are beyond the scope of this class. You're going to deal with them again when you get to data structures, and you'll get to them in other classes as well. But you do need to basically understand how to use an array list here. So you would say array list, then you would have these angle brackets, and inside those angle brackets, you're going to specify a type. So in this case, we're saying that it's an array list of strings called name, and you do call new on it, much like you would for an array. The syntax at the end is even more goofy because you still have to put in the type, and then you have to put in parentheses at the end. So you just have to get used to that. I don't know what to tell you. All right, so what else can be here instead of string? Well, you might think I want an array list of integers. I would just type in int there, and you'd be right, almost. The problem is that it doesn't take primitive types in Java. They must be of an object type. So if you want an integer, that's a primitive type, and the solution to that is they give you in Java an object called int, which is it is an object that wraps around the primitive type int. And the only way that you know that you're dealing with the object is that it uses a capital I instead of using a lowercase I. So the type is int, all lowercase, but the object that wraps around the type is capital INT. And so that gives you an object, and then you can make an array list of objects. So to be clear, if you wanted an array list of integers, you would say array list, angle bracket, int with a capital I, close angle bracket, whatever the name you want, equals new array list, yikes, angle bracket, capital I, lowercase nt, close angle bracket, and then your parentheses and your semicolon at the end. All right. If you're wanting longs, it's going to be capital long, and so on and so forth. There's a capital there's a capital, that is hard to say. There's a capital double, there's a capital float, and there's a capital boolean, and all the rest that you would expect there to be. If you're making it of type dog, then you probably already made the dog named capital dog. It doesn't have to be capital, but by convention, when you make an object, you name it with a letter that starts with a capital letter. So when you made the dog objects in the previous examples, it was capital DOG because it's an object. All right, just a convention. All right, so the initial capacity, I'm sorry, my tongue is not working today. The initial capacity of the array list in Java is 10, and that's a detail that's not really very important to you. It means that there's 10 slots that you can put things in immediately. Once you put in the 10th item, it will automatically grow and make it larger than 10. So there are attributes you can ask. You can ask for the capacity, which tells you how many it can hold, which you really never care about because it's automatic, so who cares? There is a size which tells you how many you've actually put in there right now, and that one's much more useful. So often in Java, you're going to ask for size. And the last thing is, anytime that you're using this array list in Java, you are going to need to import Java util array list at the top of your program, otherwise it won't work. So you need that import statement down there. All right, so that's the Java side. Let's talk about the C# side. So the closest thing that exists to an array list in C# is actually called list. And that's what I would recommend that you use most of the time. I'm going to explain array list as well to you, and I'll tell you why that there's a reason you probably want to use list. So much like in Java, you're going to say list, there's going to be angle brackets, but in your case, you can use primitive types or objects. It allows you to just type int, string, float, double, or dog. Names equals new, list, and then again in angle brackets, the same type. These two types must match. You can't say it's of type int and then use type double. That's not accessible. So again, you can put any type in here, primitive or complex, complex meaning it's an object, and that will give you a list of that type. Once you've defined that, you can only put that type into that array list. But you can have other array lists. You can have an array list of integers and also an array list of longs if that's what you need. All right, the capacity here starts off as 16. Again, you probably don't care. You're probably going to use count, and that's distinct from size over here. It was size in Java, it's count in C#. And you can access them directly as if they're an array in C#, which is really cool. So I can say names, and then I can do square bracket 1, close square bracket, and that's just like it was in an array. It will access the second cell, which is numbered number 1. All right, if you're going to use these, you're going to be using systems collections generic, which is going to have to be at the top of your code when you start off. All right, so that's list in C#. Let's talk about array list in C#. So as you can see, the syntax for an array list here does not include that weird angle brackets with a type in there. And the crazy part about the array list in C# is you can mix and match. The first entry that you shove in can be an integer, and the second entry you shove in can be a dog, and the third can be a long, and the fourth can be a boolean, and the fifth can be a student. And it's okay with that. The cool part is you don't have to worry about that. You can stick stuff in, but the downside is when you go to pull it back out again, you're going to have to convert it back to the type because the type is lost when you put it into an array list. And that adds an extra bit of complexity. And this is why I would say you're probably going to want to use list more than you're going to want to use array list. So list in C# closely resembles array list in Java. In both of those cases, it is made of a specific type at the time that you declare it. When you put things in, it must be of that type. When you take them out, they are assumed to be of that type because that's the only thing it can do. Array lists in C# do exist, but they can hold a mix of any type of objects when you put them in, and primitives mixed all together. So when you pull it back out again, you're going to have to convert it back using what's called a cast. This is not something we're going to talk about for a few weeks. Later on in the semester, I'm going to have a whole lecture about casting. But for now, let me give you the short version, and this is relevant to both the C# and Java people. If I say double y equals 7.3 in my code, that of course makes sense. But we know that if I were to say int x equals y, that's not going to work because I declared y to be of type double, and then I'm trying to assign a double to an integer, and the compiler says, what are you trying to do here? That doesn't make sense. The double has a period in there, 7.3, but the integer doesn't accept a 0.3, so what exactly do you want me to do with this 0.3? It's fairly obvious you want the x to be equal to 7, but do you want to round up? Do you want to round down? Do you just want me to throw away the digit at the end? What do you want from me here? So the compiler will not let you do that. If you really, really want to do that, then you can do a cast, and this is what's happening here. What I'm saying is, take the variable y, which is of course a double right now, and cast it as if it is an int, then assign that to x. This says to the compiler, I know what I'm doing, just trust me. I want you to convert this double into an integer. So what's going to be the value of x? Well, in the case of a cast, it's just going to throw away the digits after it, because you took something that was very specific and you made it less specific. So it said, okay, sure, whatever, it's 7. If that's not what you meant, you probably should have done something else. So that's what a cast will do here. And the reason I'm bringing that up is, if you put things into an array list in C#, the array list does not care what type they are. So you can put an integer in the first one and a double in the second one. But when you pull it back out, it is not of type double. You're always going to have to do a cast on front of it when you get it back. So that's why I would recommend, you probably don't want array lists, you probably want lists. All right, so there you go. Okay, so array lists versus arrays. Why do we have both? Well, the cool part of array lists is that they can grow and shrink, as I've said before, whereas arrays are just a fixed site. Array lists can hold objects, whereas arrays can hold objects and primitive types, so that's different. And to be clear, that's really only in Java. In C# they can hold primitive types. Data it holds is homogeneous. The data it holds is of a specific type. That's pretty much the same thing. So how do you go about getting stuff in and out of an array list? Well, we have a couple of methods. We have an add method in Java and an add method in C#. So once you've defined an array list with that crazy line of array list, angle brackets, int, my array list equals new, array list, angle brackets, int, open, close, parentheses, semicolon, then you can say my array list dot add, and then you can put in whatever it is that you are allowed to put in there. So if it was an array list of integers, I can stick a 7 in there and it'll work great. If I want to remove one, we have a function called remove, and we also have a function called remove at. We also have our size and our count, and in Java, if you want to get one out, you use the get method and you pass it a number inside of those parentheses. So if you want to get the first element, you would say myArrayList.get parentheses 0. In your C# world, you would say myArrayList angle bracket, or sorry, square brackets 0, just like an array. All right, so this is just a quick sampling of the methods that you get. How would you figure out what other methods are available? Well, I went to Google and I typed in ArrayList Java methods, and it gave me back this article, which is an Oracle doc because Java is owned by Oracle these days. And you're going to find one of these for pretty much anything in the Java language. So this is in the spirit of teaching you to fish rather than trying to remember something. You're never going to remember every possible method that's available on every single object. It's okay to go Google it. As I was writing the examples for today's lecture, I had to go Google some of these method names because I could not remember what they were, even though I taught this class before and blah, blah, blah. So how do you get the list of methods? If you scroll down here, it says method summaries, And then you're going to see that it has an add. It also has an add with another type, so it takes an index and an element versus just taking an element. And you might say, why does it have two adds? Well, it's called method overloading, right? There's two different versions of add that take different sets of parameters. They return different types. So this one returns a void, whereas that one returns a Boolean, if it can. Add all, we have a clear, which removes everything from the list, clone, which will make a copy of the list for you, contains, which will search through and see, is this particular object in the list? You get a get method, that's how you get things back out again. Is it empty? Can you give me the index of this object, i.e. where is it in the list? These are all cool things that you never had in arrays, right? So you make an array and you put 5 numbers in there and you want to know, is this number in there? Well, you have to write a for loop and then walk all the way through the array and say, is it this one, is it this one, is it this one, is this one? Array list, you can just say, give me the index of this value, or is it empty, or is the give me the last index of this, or remove, which there's a bunch of them, and remove all, and size, and sort. Hey, you can just sort the whole list if you want. And so on and so forth. So these are the methods that you have for here, and it also shows you the constructors, and it gives you a brief description at the top as to how this particular thing works. It also tells you what you have to include in order to be able to, what you have to import in order to be able to use it. So this is how you do it in Java. How would you do that same thing in C#? Well, you're going to end up at a Microsoft document in C# because they own C#. So again, all I did was I typed in list methods C#, and that brought me to this article. And again, up here at the top, it's going to give you some information about it. It's even going to give you a couple of nice little examples, which is better than the Java docs, because the examples are how you actually learn things. At least if you're me, you go and look at the example. You don't actually read the list of them. And then it lists down here all the properties. So capacity and count, we talked about those a moment ago. It tells you that you can pull out any one item by saying item at position whatever. And then you have your methods down here. So there's an add method with a capital A. There is a clear method, a contains method, a copy method, and so on and so on and so on. So much like what we saw on the Java side, you can get this article and you can pull this up. And look, you're always going to have access to the internet. There's never, okay, when you're on the test, you're not going to have that. So you do need to remember at least the basic methods. But in the real world, when you're coding something, you're always going to have access to these documents because they change. The methods that an array list has or a list have in C#, in 2 years they may have 2 more methods that they support where they've added something in there. And it's cool to be able to find that. So it's real important to be able to go out onto the internet and find the actual answers you're looking for, and that's why I'm doing that right now. Okay, so having said all of that with regard to our array lists here, let's take a look at a couple of examples for this array list. Actually, I'm going to cover a couple more things and then we're going to go look at the example. All right, so the next thing is that you can use a for each loop with an array list. We've already said that you can use a for each loop with an array, and so it kind of makes sense that it would work with an array list. If you're over in the Java world, this was the syntax of a for each loop. And so to be clear, classroom here is presumed to be an array list. So you've previously said array list student, because we know that each of the elements are of type student from here. So array list student classroom gets new array list student parentheses. And now you have an array list. And now you can iterate through all of those. And again, what that will do is it will take your array list called classroom and it will pull out the first item automatically for you and assign it to S1. And then it's going to do everything between the curly braces. So whatever you want to do with S1. Warning, you cannot change S1 inside those curly braces. You can't remove or add one into the array list while you're doing a for each loop. If you need to do that, you're going to need to do it with a for loop. Why? Because there's a concurrency problem. All right, think about it this way. Let's imagine I have 2 ATM cards and I want to be very, very clever. So what I do is I have $100 left in my checking account. I get a buddy and I send him to another ATM and I stand in front of an ATM and we get on the phone together and at exactly the same moment we both put in the card, we both type in our PIN number, and then we both say withdraw $100 at the same exact moment. Beep! What's going to happen? Well, if the bank is smart, one of us is going to get $100 and the other one is not because it realizes that you're both trying to do it at the same time. But the bank has to be pretty smart to notice that. So this is an example of a concurrency issue. 2 different things are trying to happen at the same moment and they're in conflict with each other. So at the moment that you do a for each loop, which is what's happening in both of these, the list of items that are in there is read once at the beginning when it sets up the for each loop. If you then go mess with that and you start adding and removing things, it's like you're trying to go to the ATM in 2 different places and withdraw the same money. It will not let you, it will produce an error, and your code will crash. So don't do it, don't add, don't remove while you're in the middle of a for each loop. If you want to do that, don't use a for each loop. All right, but if you're just trying to print out all the things that are in there, a for each loop is an awesome way to go. So again, what happens here is this is your array list, this is each element in the array list, and then it's going to run through the code. This is the same code for C#. The syntax is just ever so slightly different. It's for each instead of for, and it's the word in instead of that colon, but it works exactly the same way except for those syntax issues. All right, so here is an example. And so we are doing just the generic array list. We're saying array list, my list equals new array list. For I equals 0, I less than 5, I plus plus, my list dot add. What is my list? My list is here, and that's this array list that we created. And we're calling the add method, so it's going to shove in the numbers 0, 1, 2, 3, and 4 into that array list. I now have an array list with 4 items. So now if I do this for each statement and I say for each x in my list, and you notice that this is an integer because what we put in were integers, console.writeLine x, you'll see out all of the integers. This is the equivalent code in Java, nothing different here except we have to specify the type, and that should be int, not integer, I believe. I think that's a typo. I believe that's supposed to be int with a capital I. Maybe it's fully spelled out. I'm not sure. So I'm going to go look that up. One moment. It totes is integer, sorry. And so there was a typo on slide 4 at the beginning of this presentation, and I've gone ahead and changed it back to capital integer. It is fully spelled out. So this slide was correct. I didn't change this slide. Apologies. Just one of those moments when you look at it and it didn't look right. So array list of type integer, my list equals new array list of type integer. And then we're doing the same thing here where we're calling add on my list, which is that array list that we just created. And we're doing the for each loop to do the print out of that. Okay, so what's actually happening with all of this? So this is the concept of an iterator, these for each loops that are going through and using a collection, which is the generic name for what we're looking at here. So to be clear, array lists, lists, arrays are all examples of collections. And an iterator is something that can walk through a collection, and this is a specific object that exists for each one of the collections that's automatically there in the language for you. And this is how the for each loop works. It's using an iterator under the scenes in order to go through all of the elements one at a time. You can directly use an iterator. It has methods like next and hasNext, which hasNext will tell you, yes, it does have a next, or no, it does not. So it's a Boolean, a true, false, whereas next will actually return the next thing from the list. And so you just call next over and over again. So effectively, really what's going on here is that when you're in the for each loop, it's just doing a while loop, and each time through, it's doing next to pull the next one back. And the exit condition in the while is hasNext. If there is a next, pull it back. All right, so this is an example of an interface, and that's a topic we're going to talk about in about 2 weeks, I think. So interfaces are something we'll have a lot more detail about, but iterators are an example of that. So specifically using an iterator here, basically we're doing the for each loop as an iterator instead, and so you can see class iterator, a variable named iter gets mylist.iterator, mylist being the array list that we created up here, and we're saying while it has a next, pull the next back and print it. All right, so that's array lists, for loops, iterators, that's what's covered in this lecture. From here on out, I'm going to show you a very detailed example of using an array list and also a list, because even though that all probably made a lot of sense, you're actually going to find that there's a lot of stuff that's extra in this example. It's also going to cover some things that we've already talked about before, and so before I get started, I'm just going to show you the 2 URLs so you can pause your video. This is the URL for the C# version. So it's replit@endasullivan arraylist-example-c versus this is the same one for Java, replit /@endasullivan arraylist.example.java. All right, so I'm going to walk through the Java one, and then the C# one is an identical set of code. There are places in C# where you can do things differently, but I specifically didn't do them differently so that the example will work for both of them. So in each case, you have the same objects, they have the same methods, and they are working the same way. They're just doing some additional stuff, and I'll talk through that as we go through it. So let me explain at a very high level what we're trying to do here. I'm just going to run this for a moment. I want to have an address book, and I want to be able to put people's names in and their phone numbers. Each person can have more than one phone number, because I could have a cell phone on the landline, and I may have a work phone on my desk, and I may have 7 different phone numbers. So it's clear that I'm going to need an array list to hold the phone numbers for each individual. But I also know more than one individual, so I'm going to need an array list to hold the actual people and their phone numbers. So this is going to be a pretty detailed example, because we're going to have an array list for phone numbers in an object called Phonebook entry, and then we're going to have an array list of Phonebook entries, which we're going to call Phonebook, and we're going to wrap both of those in objects just to make this all a little bit clearer. So I'm going to show you how it works first, and then I'm going to go through and I'm going to do stuff. So I'm going to say I want to add a person, so I'm hitting 2 from this menu, and it says what's the name of the person. It's Enda. What's the phone number? 404000. I'm going to add another person. This is Bob, and Bob's phone number is 770-111-1111. Cool. Now I'm going to say show me all of the people, and I'm just going to move my little window up to the top here so that you can see everything that came out. So when I said 1 to show me all the people, it said there's Enda, that's his phone number, there's Bob, that's their phone number. And I can keep adding people as I'm going through things. But I can also add another number to a person. So I'm going to do that real quick. So I'm going to say 3. What is the name of the person you want to add a phone number? I'm going to add one to Enda. And this time it's going to be 678-333-3333. All right. And then I'm going to say show me all the phone numbers. So now you can see that Enda has 2 phone numbers associated with him because, well, he does, because I told him that he does. All right. And then finally, I have the ability to delete a person because I no longer like Bob. So goodbye, Bob. And it says cool, and when I see all the numbers, Bob is dead. All right, and then at the end, I can obviously quit. So that's what's happening. Couple more details about what's going on here. The phone numbers I'm going to store just as a long, which does mean you can't put parentheses and dashes in there. It's just going to be stored as a long for this example. So it's a long number. The names are going to be stored as a string. So the first thing that I need to have is I need to have a Phonebook entry which holds the name and all the phone numbers for one individual. Okay, so let me be clear, this is for one individual, this Phonebook entry, which is distinct from Phonebook, which has all these Phonebook entries in it. So I've created a class here, and at the top I am importing Java util ArrayList because I'm going to use an array list in here. If you don't put that in there, you're going to get a compiler. All right, so I begin with class Phonebook entry, which makes sense, hopefully, and I say that I have a private string named name. All right, that's going to hold the name, Bob, Enda, whatever the name is. I also have a private array list of type long called phone numbers, and it gets a new array list of type long. Cool. All right, so now we're going to need a couple of constructors. So the first constructor I'm going to do is kind of like the default constructor. It's going to take in no parameters, and I'm just going to set the name equals blank, and I'm not going to do anything with the phone numbers because I don't know any phone numbers, and the default state of an array list is it's blank, so sure, that all works well. The second constructor, which is an overloaded constructor again, this one's going to take in a name, and I'm just going to set the name to that name. So I have the option of creating an entry with just a name. And then the third one is it takes in a name and a phone number, and it sets the name, and then calls add number on the phone number. So what is add number? Well, that's a method that we have down here. So this is a public void, add number, takes in a number, and it simply says phone numbers, which is the name of my array list from up here, phone numbers.add, and then the new number. Now you might say, well, how does it know whose phone number this is? Remember, this object that we're dealing with, or this class, when it is instantiated as an object, it will hold one person. So it's just adding a number to the current person. Each version of this, each object of type Phonebook entry will be representing one individual. So there is an object for Enda, and there is an object for Bob, and an object for Sally, and an object for Jane. Each of them has its own array list that can have unlimited numbers in it, and one name for its string. So add number is a method that can be called either in the class or outside the class because I made it public. So I can say enda.addNumber, and then I can give it a number. Or the constructor can call it, which is what's happening up here at the time that a number needs to be added. All right? So next up, we have the need to be able to remove a number. Well, this is a little bit complex because they're going to give me a number to remove, and I would have to go figure out which one of those numbers is the one I'm trying to remove. So I want you to picture an array. As a matter of fact, specifically, I'm just going to draw this real quick, just so that you can visualize what this is looking like. Hopefully we get a blank screen here in a second. Okie dokie, we don't, of course. This was from a different class, and we're going to clear that, and then we're going to turn on the pen. All right, so the class that we're dealing with is called Phonebook entry, and what I want you to picture is a box. And it has a name, and it has a phone book, which is this magical array list, which, again, I want you to picture like it's an array. I'm drawing it just this way because I'm running out of space. Usually you picture arrays as being like this, but of course they work either way, right? And it's just how you're picturing it. That's not how it really is in memory anyway, so who cares? All right, so this is what your object looks like. It looks like a wrapper that has a name and a phone book. Why is that how it looks? Well, because if we go back and we look at the very top of the class, those are the two things that I defined as attributes. There's phone numbers and there's name. Those are the two things that I can store in there. All right, I wrote the wrong word, of course. That is supposed to be phone numbers. All right, which is my array list. Okay, so when I add an entry in there, the first phone number, which was 404 whatever, goes into slot 0 of the array. The next one that I put in will go into slot 1, and so on and so on. And this can grow infinitely. There is a ... implicitly at the bottom of that array, because dots don't show up very well on the screen, but there is implicitly a ... down there, because that can be of any size depending on how many phone numbers I have. What nefarious thing am I doing that I have this many phone numbers? But anyway, all right, so that is what my array list is going to look like. So when I say I want you to delete phone number 4040000, you're actually going to have to look in each one of the cells. You're going to have to look in cell 0 and see, is that the right one? And then look in cell 1 and see, is that the right one? And then when you find it, you're going to call remove on whichever cell number you found it in. So if it was in the third cell, i.e. cell number 2, you would say remove 2, meaning array list dot remove 2. All right. So now let's look at the actual code that we did for this. So that's what we're trying to do here. We're trying to remove a particular phone number from the array list in this class. So I take in the number that they want me to remove as a parameter. So this can be called in the public. So somebody can say enda dot remove number 404000000. And then what I'm going to do is I'm going to say for I equals 0, I less than phone numbers dot size I plus plus. All right, phone numbers dot size means I'm asking the array list, how big are you currently? If it's currently 0, then this loop's not going to do anything. If it's currently 1, then it's just going to go through once. If it's currently 100, it's going to go through 100 times. All right, and for each of those, it's going to look and see, is this the one that I'm trying to remove? And the way that it looks at it is, it says, all right, when we're on cell 0, I want you to get for me the value from cell 0, which is going to be a long number, and I want you to compare that to the number that we're trying to remove. If that is the same thing, i.e. we found the one we're trying to remove, then I want you to do phone numbers.remove at position I. And that's going to successfully delete it for you. All right. There is a small gotcha in all of this. Remember I told you about being careful about changing the array list using a for each loop. You absolutely can't do that. And I'm not doing that. I'm using a for loop here instead of a for each loop. But I still could get in trouble because if I removed enough things out of there, it could choose to shrink the array list because of that remove. And the shrinked value could be smaller than the original size, so I could then go out of bounds at some future time. So this isn't exactly the safest thing. What should really happen is, if I find it, I should also jump back out of the method at this point. I should probably add in here a return, because that'll guarantee that the moment I find it and I remove something, I just stop looking, because I found it. There's no reason for me to keep going, right? Okay, so I also give the public the ability to change a name. That's pretty easy. I take in a new name and I set the name of the object to new name. I have a getter method, which will give back the name in case you want to know what the name is from this particular object. So get name. And again, this is because I may have called the object X or Y or Z in my code, it would be nice to know the actual name of the person that X represents. So that's why that's there. And then the last thing is I'm doing an override on toString. And this allows me to say system.out.println or console writeline enda. And it will just print enda and all the phone numbers, which is exactly what's happening here. So what this says is, I want you to set up a string called all phone numbers, and then I want you to use a for each loop to go through all the phone numbers that you get out of phone numbers, and one at a time add them to a string with a carriage return at the end. So this is maybe some syntax that you haven't seen before, so I'm just going to cover this real briefly. Anytime that you specifically want a carriage return, you know that you can use system.out.println or console.writeline, and both of those will automatically put a carriage return at the end. But if you want a carriage return somewhere else, then you're going to use a /n to represent a carriage return. So hopefully that's not too new. You always put those in double quotes. So to be clear, what happens here is my string all phones starts off as nothing. It's an empty string. The first time I go through the array list with my for loop or my for each loop, it pulls out the first number, which was 4040000, and it assigns it to P. That's how for each loops work. We then go through and we do everything between the curly braces, and what it does is it says, take all phones, which is that string that currently is empty, add to it, that's a plus equals, which is the way of saying I want to add to something that works on strings as well, add to it P, which is the current phone number, 404, and a carriage return. Then it's going to go back up to the beginning of the for each loop, and it's going to pull out the next number, assign it to P, go back in and do the same thing again. And so all phones, which is a string, which originally had nothing and then had 4040000, is now going to get, and a carriage return, is now going to get 6783333 and a carriage return. So at the end of this for each loop, all the phone numbers will be in there, one per line in that string. And then the rule of a toString method that I'm overriding is that it must return a string. So in the end, I return name colon plus name, a carriage return, phone numbers colon carriage return, and then all the numbers that I just calculated up there. I have to do this part first because you can only return once, but I need to be able to do in a loop, put something together into a temporary string, and then I return it as part of the flushing of all the data back. So this gives me a method to return back the string that represents that one entry, the entry for Enda with all of Enda's phone numbers, or the entry for Jill with all of Jill's phone numbers. All right, so that completes this class. I have a class called Phonebook entry that holds one name and an unlimited number of numbers, and it has some basic methods for manipulating that to add and remove numbers, and it also has the toString method, which will give me back the string. All right, so now that I have that, what if I want an array of them? Because I want to be able to store more than one number. So I'm going to need another class, which I'm calling Phonebook, distinct from Phonebook entries, which also has an array list. This array list, which in this case is public, although it probably should be private, this array list is of type Phonebook entry, which is the previous Java class we just talked about. So I have an array list that holds objects. Each one of them is a Phonebook entry, where there's a name and a bunch of phone numbers in there. So ArrayList Phonebook entry, I'm calling it Phonebook, that's my variable name, gets new ArrayList Phonebook entry. All right, so now what methods am I going to need for the Phonebook? Well, I'm going to need to be able to add somebody to the Phonebook. I'm going to need to be able to remove somebody from the Phonebook. I might need to be able to add a number to somebody, and I might need to be able to print out all the entries in the Phonebook. So let's start at the bottom one because that's the easiest. If I want to print out all of the entries in my Phonebook, I can simply use a for each loop. So I'm saying for Phonebook entry, and I'm calling it PBE because Phonebook entry, for Phonebook entry PBE colon Phonebook. So Phonebook is the name of my array list up at the top here. And what I'm saying is I want you to iterate through Phonebook, and one at a time I want you to assign each of the Phonebooks and each of the Phonebook entries that you're getting back to a variable called PBE. And now I'm simply calling system.out.println on PBE, which is going to invoke the toString method because it's trying to print an object. And if you try to print an object, it's going to call the toString method. That's how that works. So this will have the effect of printing out all of the entries in the Phonebook. Each time, it's basically asking the Phonebook entry code to print out that one, but it's just doing a loop around them saying, okay, now you print out the one, and you print out yours, and you print out yours, and you print out yours. All right, so hopefully that makes some sense. So let's talk about how you add somebody to the Phonebook. So again, Phonebook is the name of my array list in here. And if I'm creating a new entry, I'm only going to allow them to give me a name and a phone number. You could obviously write different versions of this add entry where it only gets a name, and another version where you get more than one number if you wanted that. But for right now, all I coded was give me one name and one number, and I will shove them into the Phonebook. So what I'm going to do is I'm going to create a Phonebook entry, which is the other class called PBE, and I'm going to call its constructor, passing it the name that I was given and the phone number that I was given. So this is going to create for me a variable called PBE, which is of type Phonebook entry. That's not the method, or that's not the class I'm currently in. It's the other class that we just looked at. And you remember that it had constructors. It had a constructor that took no parameters, a constructor that just took a name, and a constructor that took a name and a number. It's that third one that's going to be called, and the thing that I'm passing is name, which I got in as a parameter up here, and phone, which I took in as a parameter up here as well. That makes for me an object called PBE. And now I'm going to add, using the add method on my array list, PBE to my array list. So I'm saying Phonebook, that's my array list name, dot add PBE. And boom, that's going to put a whole object of type Phonebook entry into the array list. It'll go into specifically position 0. So in position 0, there is an object that is of type Phonebook entry and has a name and an array list of phone numbers. In cell 1 of my Phonebook, there's nothing, because I didn't put anything in cell 1 yet. The first entry goes in cell 0. If I call it again, it'll put it into cell 1. If I call it again, it'll put it in cell 2, and it will keep going. So this can grow infinitely. All right, so how about if we need to remove something out of my Phonebook? Well, again, we're going to allow them to give me a name, and I'm going to take the name and remove that. You saw me do that a moment ago when I deleted poor Bob because I don't care about him. So I'm going to take in a string, which is the name of the person that I want to remove, and effectively what I'm going to have to do is I'm going to have to go through the array list and look for Bob, which is not really easy because the array list is of type PBE, or sorry, Phonebook entry. So I have to actually go through the array list and open up each of the objects that it returns from each cell and look at the name inside of there. So that's what I'm going to do. I'm going to say int I equals 0, I less than the Phonebook size. Now this is not the phone numbers, this is the Phonebook, I++. So at the moment, if I've added Bob and Enda, there are 2 entries in here, and that size is going to return 2. So that loop is going to happen 2 times. On each iteration, it's going to take the current Phonebook entry and assign it to PBE. This is kind of like what a for each loop would have done for me, but remember, I'm about to modify the array list, and you can't do that in a for each loop. That's why I'm doing it in a for loop. So I'm pulling out that object that I get from position 1 or position 0 using that get method on Phonebook. So the first time through, that will say Phonebook.get position 0. And that's going to pull out the item that is in position 0 of Phonebook, which happens to be an object of type Phonebook entry. I'm assigning that to a variable that I'm calling PBE. All right? Good Lord, stop giving me hints. Stop it. There we go. All right, so I'm assigning that to PBE. Next, I need to see, does that object's name equal the name that I'm trying to get rid of? So the name that I'm trying to get rid of came into me as a variable called name to remove. And it's a string, because that's what a name is. So I'm going to say name to remove dot equals pbe.getName. There was a lot going on there. So let's talk about the bits individually. So PBE was the object that I just pulled out. It's of type Phonebook entry, and we know that that has a method called getName, which returns the name of the person, which in this case would be Enda. So this all gives me back a string, which would be Enda. Don't do that. Ugh, cannot highlight today. All right, that gives me back a string, which would be Enda the first time, it will be Bob the second time. All right, name to remove is what they gave me that they wanted to remove. Bob, Fred, Jim, Jill, Jane, whatever. And so what I need to do is the name to remove equal to the name of the one that I got out of the object that I'm now looking at? And you might say, why did I not just write in here equals equals? Well, there's two ways to compare a string in Java and also in C#. Equals equals checks to see if they are literally the same string, meaning that it's the same object string. If they are identical, meaning they're actually the same string, then it will pass as true with an equals equals. But if you have two different strings, you make two different objects, each of them happens to have the same text in them, and you do equals equals, it will return false because they are not the same actual string. The way that you compare two strings in Java and in C# is you use the equals method. So string name dot equals is a way of saying, is the text inside this string the same as the text inside that string? This only applies to strings. It's just one of those weird things that you have to get used to, but you're going to have to call equals. I will be honest with you, when I wrote this code first time, that was an equals equals, and it didn't work. And I sat here and tried to debug it for a while until I remembered, oh, that's right, strings are weird, and you have to call dot equals on strings. All right, so to review, we got back the name of the first person in the phone book by doing this, pulling out the object from the array list and then doing get name on it. We check to see if that name is equal to the name that was given to us. If it is, then we're going to call phonebook.remove, and we're going to pass it the particular object we wanted to remove. So the cool part about ArrayLists is you can just pass them an object that is of the specific type of the array list to the remove method, and it will go find it and remove it. So that works out really well. Why is this nonsense about hit in here? Well, it occurred to me when I was trying to debug it that it would be really nice if it told you, I never found a Bob. So let's say you make a phone book and you have an Enda and you have a Bob, and then you say remove Jill. Well, there is no Jill. It would be nice if it actually told you that it didn't do that, because up until now it wasn't giving any output. So the way that you tend to do stuff like that is you might set a variable of type Boolean to false. Then you go through your for loop or your for each loop or whatever it is that you're doing, and if you ever succeed, you change the Boolean to true. When you're done with your for loop, if the Boolean is still false, you know you didn't find them. So this will only fire if this never hit. That's why I call it hit. You know, it's like you're shooting at something. Did you hit it? Well, you start off, you say, I haven't hit anything, then you do whatever it is that you're going to do to try and hit it. If any of those succeed, great, you hit it. If not, you didn't, at which point you're going to say, no, I didn't actually find that. So this will just give a little bit of debugging information to the user if they try to, say, delete an entry that isn't in there, so that they know that they can go look at the list and then figure out what they meant to do. Okay, so that's the remove entry. So again, to review where we are still in Phonebook, which has this array list of phonebook entries, and we're trying to remove an entry that completes that. So the last method that we're going to look at is add number to a name. So the idea here is Enda already has two phone numbers, I want to give him a third one. So we're going to need to prompt the user and ask them for a name and a new phone number, and then we're going to call this method with that name and that new phone number, and it's going to go through the array list, looking at each one of the phonebook entries in the array list, check the name and see if that's the name that we're trying to add a number to, and if it is, then it's going to call the add number method. So the way this works is identical to the remove. Again, I set a Boolean hit equals to false. This time, because I'm not actually changing this array list, I'm changing an inner array list I have an array list of phonebook entries. I'm not changing that. I'm changing the array list inside each phonebook entry, which is not going to affect this for each loop. I'm not adding and removing from the outer array list. So I can use a for each loop here. So I said if name.equals, and again, that's the name that came in here, if it equals to the phonebook entry get name for the particular one that I'm looking at, then I'm going to call add number, which is a method that's over here in phonebook entry, passing it the phone number, say that the hit was true, and life is good. So that is the phonebook entry and the phonebook classes. Let's take a look at main, which just does the actual printing and reading of the menu. So over here in main, I start off and I create a phonebook of my phonebook object, and I call it my phonebook. I set up a scanner because I'm going to need to read an input from the user, and then I'm going to need a variable called choice, which is what they're going to type in for their menu, and I'm going to have a do loop, which is going to end when they type in 5. So I'm going to keep doing until they give me a 5. Inside the loop, I'm simply going to print out the menu, bada bing. I'm going to read in their choice, bada bing. I'll explain one detail in the comments there in a moment. If their choice is 1, then I'm going to call phonebook print all. If their choice is 2, then I'm going to ask them what's the new name of the person. I'm going to read in that name. I'm going to ask them what's the new phone number. I'm going to read in that phone number. And then I'm going to call add entry, passing it the new name and the new phone number. Likewise, if they're doing 3, which is to add a number to a person, same kind of idea. And if they give me a 4 to delete, I'm eventually going to call remove entry on whatever name that they enter. All right, so the one detail that I'm going to explain that's specific to Java is a weird thing about the scanner. When you read in a number from the scanner, when you say next int, it does not capture the carriage return. So what does that mean? So when this menu popped up over here, if I run it again, it gave me the menu, and then it expected me to type in a number. Because in the code, so I'm going to hit 1. In order to type in the number, you notice that it didn't do anything when I typed in the 1. I have to hit enter on the keyboard before it actually does something. So in actuality, what I typed in was the number 1 followed by a carriage return. In my code, when I said next int, it read in the 1. It did not read in the carriage return. So as a result, if I then do a next line, I will get a blank line because the next thing that it reads out of the keyboard buffer is that carriage return. So anytime that you do a next int, you're going to want to do a next line afterwards to swallow that carriage return that's sitting in the keyboard buffer. This is a weird Java thing. The other way to do it is always read it in as a string and then convert it to an integer. But if you're going to go back and forth between next int and next line or next long, if you're switching between those methods, you're going to need to always swallow the next line when you do a next long, next int, next float, or anything other than next line. If you do a next line, you don't have to do it. So you'll notice up here when I ask for the person's name, I don't do it. I just say, give me the next line, because that includes the carriage return. But when I say, give me the next long, I then have to swallow the carriage return. That's a weird Java thing. I don't know what to tell you. So that's all the code. You guys can go grab that from here. And again, inside of Replit, if you press that little down arrow that's hidden right there and you say fork, it will give you your own copy of this code and you can go play with it. I would suggest adding in additional functionality. What happens if I want to remove a number from a person? So not only do I want to add a number to that person, I may want to be able to remove a number, which should prompt me for the name of the person and then prompt me for the phone number, and it should remove it. Maybe you want to be able to add a person with 2 phone numbers up front. So you have an option for add person. What happens if you need another option for add person with 2 phone numbers? You could add that code in if you just want to play with this and practice with this array list, which would be a great thing to do. I'm going to briefly talk through the C# code because, again, I literally copied and pasted the code from the Java window, and then I just did the changes that had to be changed. So the import statement became a using statement, and I have to use system collections generic because I'm going to do this with a list, not with an array list. My array list is of type long here for my phonebook entry. It's not capital long, it's just regular lowercase long in C#. Down here, when I do add, to add an item to the array list, it has a capital A. And when I pull back out the size, instead of saying .size, I say .count with a capital C. When you try to remove something, you use remove with a capital R. So most of the time, the method names are the same, count and size being an exception, but add and add, remove and remove, it's just that they have a capital letter. So you usually have to go through and change those kinds of things. The syntax of the for each loop is ever so slightly different because you have the word in and it says for each instead of the word for. When you're overriding toString, the word override happens in the method definition, and the name of the method that you're overriding is toString with a capital T and a capital S versus a lowercase t and a capital S. In Phonebook, the list is of phonebook entry. That's not different. That's the same. The add method has a capital A. The for loop uses .count and .remove. Most of this is all the same. I don't remember having to change anything in here other than obviously the console write lines instead of the system out print line. And down here, C# is wonderful at sometimes. There are some things that you will hear me give a 5-minute explanation for in Java, and it just doesn't apply in C#. In C#, you always read in a line, and then you use the parse method to parse it into whatever particular type you want to parse it in. So there's no nonsense of having to read in extra carriage returns or anything like that. So that just works better. So what you'll see here is there's an extra line on each one because I read in from the console as a string. So I have new phone raw equals console readline that reads in the whole line, and then I have to parse into a long the raw, and that gives me back a long number, which is the phone number. Other than that, the code is the same all the way through. So those are two big examples. They go over a lot of stuff that we've covered so far, so hopefully they're useful, and I would recommend that you grab this code and you play with it a little bit, because it does cover things like creating classes, instantiating classes, having variables that are public and private inside of classes, for each loops, which are handy to remember, the array lists and lists, obviously, that we're using in today's class, and then just general syntax of reading things in and printing things out and passing variables into methods and stuff like that. So hopefully this example was helpful to you guys, and this completes the lecture on array lists.